This is Republic Polytechnic, a renowned institute of higher learning in Singapore.
Republic Polytechnic, RP, was set up in 2002 with the mission to train mid-level professionals to support the technological and the economic development in Singapore. RP strategically adopted problem-based learning, referred to as PBL, as a core pedagogy for all of its diploma programs, leveraging on a social constructivist approach to design its academic system and the school infrastructure. RP is a comprehensive polytechnic with more than 14,000 students from 7 academic schools. The School of Engineering is the biggest in RP, with a student population of more than 3,000, offers 9 diploma programs. The school organizes modules around the problems. We have a smaller class size, 25 students per class, 5 teams with 5 students per team, guided by a staff facilitator. In order to support the problem-based learning, most of our laboratories are living labs on campus. At the same time, we work very closely with the industry in Singapore. We also work with the industry final year project and on-site learning, industry talks in class, or industry-endorsed problem statement or real-life scenarios. We also set up joint laboratories to conduct applied research and development. All this deep integration with the industry enrich the students' learning experiences in RP. Also prepare our students to be more ready for the industry.
In the School of Engineering, we have 3 aerospace diplomas. For the aerospace diplomas, we have designed an aerospace hub. This aerospace hub resembles an actual aircraft engineering facility. It houses 3 aircraft maintenance engineering components, and a composite repair facility. Students get the opportunity to do aircraft maintenance tasks such as assembly and disassembly of aircraft components with actual aircraft maintenance tools. On top of that, they also get to do maintenance tasks such as assembly and disassembly of aircraft components, landing gear retraction, and engine runs. For the aviation management students, we have installed a virtual aerodrome laboratory. Within this laboratory, students get to role-play the role of air traffic control officers and pilots in a simulated air traffic control tower. The industry engagement involves working closely with industry to solve their problems, to look at issues that come out in daily operations, and to bring this to classroom so that students will be able to understand exactly what it is that industry needs and what solutions the industry needs. Our industry collaboration is extremely strong with companies like Changi Airport Group, SATS, and other aerospace maintenance and repair organizations, and this enables students to get internship for a period of 5 or more months, and they also do industry-related projects for these companies.
The Engineering Design Studio is an experimental and creative learning space for students. Over here, students are facilitated through the design thinking process and given opportunities to tinker and transform their design ideas into reality. In the engineering design modules, students will interview and get feedback from product users before moving on to prototyping and finally presenting their design solutions. The problem-based learning approach facilitates students to think how they can apply engineering principles learnt to solve their given problem. It requires them to recall what they have learnt so far, what they don't know, and what else they need to find out in order to solve the problem. Students will also submit a reflection journal on their learning journey each day, sharing with their lecturer on aspects which they did well and which they need to improve. The Supply Chain Innovation Laboratory is an example of a living laboratory where there is realistic enactment of industry operations and practices for students to access easily in their daily course of learning. The equipment housed in this facility are state-of-the-art and in some cases support exploratory and research work to point the way forward for industry.
The School of Engineering at Republic Polytechnic places a strong emphasis in making sure that our students are industry ready when they graduate. As such, all our programs are strongly integrated with the industry. In the area of supply chain management, besides having classes at regular classrooms, as well as our state-of-the-art supply chain innovation lab, We also bring our students out for external classes on site at real company operations, such as warehouses, distribution centers, and even retail facilities. We're happy to share that we have many industry partners who supported us in various initiatives that we have rolled out. One such example is the Skills Future Enhanced Internship Program with structured curriculum that we have worked together with our participating companies to develop training program for students during their internship. We also work closely with various government agencies to support the growth of the logistics industry in Singapore. Another unique offering at RP is our Centre of Innovation for Supply Chain Management. Our students will have the opportunity to participate in the consultancy projects undertaken by the centre. This will allow them to learn the latest trends and solutions that are available today as well as in the future. Our students are strongly encouraged to participate in national and international competitions, to pit their skills and knowledge against the best from other institutions, and also to apply what they have learned in RP. One such competition is the Supply Chain Challenge, organised by the Singapore Logistics Association and the SIM University. Our students have done well, winning the competition 3 years in a row from 2013 to 2015. This is a testimony to the effectiveness of the curriculum at RP.
Over at the Robotics Laboratory, students learn through taking on challenging projects that have potential industry applications.
As part of the DEEE curriculum, we have learned embedded system programming, PCB prototyping, and other electronic-related modules. And my groups and I wanted to apply all this knowledge from what we have learned to interesting applications. Then we felt that the underwater robot is the best platform for us to proceed the next step. That's why we have chosen the underwater robot as our final year project. We met obstacles in every stage of the project. Mechanical electronic design of the robot and the fabrication of the design and the programming of the robot to complete all the tasks. We use the PBL system, which is the problem-based learning system, to overcome all these problems. It's quite enjoyable for us to see the completion of our robot.
With problem-based learning and deep integration with the industry, then our students can hit the ground running on the day one. We have received very positive feedbacks from industry that our graduates are professional, problem solver, and passionate citizens.